video I will explain you what are the different types of combination to join the resistors. So there are two different types of combination. One is series combination and second is parallel combination. In previous video I have already explained you about series combination. In this video I will explain about parallel combination. So what is parallel combination? If suppose we are taking these three resistors are joined in parallel combination. What is meaning of parallel combination? It means that current is divided into two or more paths, that is parallel combination. Now if we are taking the initial part and end part of each resistor, that is directly connected to the battery. Now if we are taking initial part of R1, R2 and R3, these are directly connected to the positive terminal of battery, and end part of each resistor are directly connected to the negative terminal of battery. Yeah. So in this parallel combination, when the current will reach at this point, so current will go in the resistor R1, that current will be I1. It will go in the R2, that current will be I2, and in the same manner when the current is going in the R3 resistor, it will be I3. And the voltmeter is also connected with in the parallel combination. Now I will explain you activity 12.6 which is given in NCERT. Now in this three resistors R1, R2 and R3 are connected in parallel combination. When we will connect voltmeter across each resistor R1, R2 and R3, it was noted that the voltmeter reading remains same. But if we will connect a meter at the resistor across the resistor R1 and across the resistor R2 and near to the resistor R3, this ammeter reading will be different, because in parallel combination the current will be different but the voltmeter reading will remain same. So this is the main point in the parallel combination, that the potential difference remains same across each resistor while the current reading will be different. Now we will do the derivation of to calculate equivalent resistance of resistors connected in parallel combination. So this is the diagram of parallel combination. In this diagram, these three resistors are connected in parallel combination and voltmeter is also connected in parallel combination. Now in all the resistors, current value will be different. But if we will note down the total current value, that will be equal to I1 plus I2 plus I3. Now this is the formula for this. If we are taking this total current, so this total current we are mentioning it as a I. So I is equal to I1 plus I2 plus I3. So now if we are taking the Ohm's law, according to Ohm's law, I1 is equal to V upon R1. Why we have written V here? Because the potential difference remains same. Now I2 is equal to V upon R2. In the same manner, I3 is equal to V upon R3, and if we are taking this I value, so this I value will be what? V upon Rp. What is the meaning of this Rp? It means the total resistance in parallel combination. Now in this equation we will put the values of I1, I2, I3 and of I. So we are putting the value of these all. So what will come? V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3. This will come. Now what we will take common? V will be common. So what will be coming here? V1 upon Rp is equal to, now we are taking V common again. So what is coming here? 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now what can we do here? V will be cancelled by this V. So what will be the formula? 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is the formula to calculate equivalent resistance in parallel combination. Now what will be if we are writing in definition form? So what will come? This 1 upon Rp can be written as reciprocal of total resistance. So reciprocal of total resistance is equal to sum of reciprocal of individual resistance. So this is the reciprocal of total resistance is equal to sum of reciprocal of individual resistance. Now we will study what are the advantages of parallel combination over series combination. Now in houses we are using parallel combination, we are not using series combination. There are so many advantages of parallel combination over series combination. Now I will explain you 4 advantages of this combination. So first advantage is that if the appliances are connected in the parallel combination, and if one appliance will stop working, then the others will remain in working. While in series combination, suppose 3 bulbs are there, these 3 bulbs are there, and if one bulb will stop working, or we can say its filament is fused, then the other 2 bulbs will also not work. So this is the disadvantage of the series combination. If one appliance will fail to work, the others will also stop working, while this will not happen in the parallel combination. Now the second advantage is that in parallel combination each appliance has its on off switch. Like suppose in your room that the 2 tube lights and the 2 fans are there. So each tube light will have a separate switch. Each bulb will have a separate switch. So in the same manner, you can check in this figure that the 3 bulbs are connected in parallel combination and each bulb has separate switch. So whatever bulb will be required, so we can switch on that, we can switch it on. Now the next is, in parallel combination each appliance will get the same voltage. If we want the proper working of each appliance, so what should be the potential difference across each appliance? That should be 220 volt, and in parallel combination the potential difference remains same, while in series combination potential difference does not remain same. So this is the advantage of parallel combination, that each appliance get the same voltage. Now the next point is, if we are connecting the appliances in the parallel combination, so what will happen to the resistance? The resistance will decrease, because what is the formula? 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Suppose we have taken 3 resistors, 2 ohm, 4 ohm and 6 ohm. These are the values of 3 resistors. So what answer will come? What is the least value out of these 3 resistors? The least value is 2 ohm. So the answer of the total resistance will come less than 2 ohm. It means that in parallel combination the total resistance will decrease. Now when the total resistance is decreased, now and according to Ohm's law, what is the formula? I is equal to V upon R. So it means current is inversely proportional to resistance. So when the resistance will decrease, it means the current value will be more. So in the parallel combination of electrical appliance, the overall resistance of household circuit is reduced, due to which more current from the power supply is